Good morning to all my students and friends. Welcome to my YouTube channel Make It Easy. Today we are going to learn about the law of chemical combination part 2. If you are new to my channel, just go and subscribe to enjoy my videos. And if you are already a subscriber, then let's continue. Without wastage of time, we will go to the most important law, that is the law of constant proportion. It was first expressed by Joseph Proust in the year 1799, and in the picture you can see this person. Now what the statement of this law again? A pure chemical compound always consists of a same elements that are combined together in a fixed proportion by mass. Very tough to understand but easy to take an example. See, suppose carbon dioxide. If we take carbon dioxide from different sources, we will get the mass ratio of carbon and oxygen as 3:8. To elaborate this example, I want to give you an idea by having some chemical reactions. See, in the example, if we take the combustion of carbon, it is carbon burns with the help of oxygen to form carbon dioxide gas. The another one is calcium carbonate. That is, the calcium carbonate when decomposes under heat, it produces calcium oxide and carbon dioxide gas. We can take another example. It is sodium carbonate. When reacts with dilute HCl, it gives NaCl, that is sodium chloride, water and carbon dioxide gas. In all three reactions, the product CO2, that is carbon dioxide gas, have one carbon atom, two oxygen atom. So the mass ratio of carbon and oxygen can be found out by in this way. The atomic weight of carbon atom is 12 gram and the atomic weight of oxygen atom is 16 gram. But here only one carbon and two oxygen atoms are combining. So it will be 12 gram is to 32 gram, that is 16 into 2, 32 gram. And the ratio will come 3:8 in each and every case. So randomly, if we take carbon dioxide from random sources, the mass ratio of carbon and oxygen will be always 3:8. Okay, that is actually called the constant proportion. That is, they will combine in 3:8 ratio. Am I clear? To have a better idea, we will do again a numerical problem. So see what the question is here. Metallic magnesium burns in air to form magnesium oxide of 5 gram. That means the product is 5 gram, where magnesium is 3 gram. Again, magnesium carbonate decomposes to form magnesium oxide of 8.5 gram, where magnesium is 5.1 gram. We have to show the law of constant proportion is satisfied over here in the information. So let us take that in case number 1, the mass of magnesium oxide formed, it is 5 gram, where the mass of magnesium is 3 gram. So we can easily calculate by the difference that the mass of oxygen is 5 minus 3, that is 2 gram, and the mass ratio of magnesium and oxygen will be 3:2 gram. In case number 2, mass of magnesium oxide produced over there is 8.5 gram, whereas mass of magnesium in it was 5.1 gram. Now in the same way, we will go for the difference, that is the mass of oxygen will be 8.5 minus 5.1, that is 3.4 gram. And now the mass ratio of Mg and oxygen, that magnesium and oxygen, will be 5.1:3.4. It will be reduced by 17, that will be 3:2. Clear? As the mass ratio of the elements are fixed, that is 3:2, we can say that the law of constant proportion is satisfied over here. Clear? Now in this video, I am just going for only one numerical problem. If you have more urge, you can write over there in the comment box to let me share more numerical problem to meet your need. Okay, but in this video we will go for the limitations of this law of constant proportion. We all know that nothing is 100% accurate, so the law of constant proportion is also having some drawbacks. We will have to move towards that. What are the drawbacks actually over here? The first and the most important is the isomeric form of compound. It is based on carbon compound mainly. Let us take an example, that is, we all know urea, that is CONH2 Over here, number of carbon is 2, hydrogen is 4, carbon is 1 and oxygen is 1. The same isomeric form of urea is ammonium cyanide, that is NH4NCO. and it is also having the same number of elements over here. They are having same molecular formula, same element are constituent over here, but the chemical characteristics are different. That means that doesn't matter if the molecules or the substances follow the law of constant proportion, will always have the chemical characteristics same. It may differ. Another example you can take, it is the ethyl alcohol C2H5OH, and another isomeric form is a dimethyl ether, that is CH3OCH3. The functional groups are different, so the characteristic of that is the chemical characteristics will also be different from each other, and hence maybe the molecules, maybe the substances have same molecular formula or same constituent element. It doesn't matter that the chemical characteristics will be same. Now the next drawback is also very important, because it is the isotopes of same element. That means we all know that some of the elements are present in isotope form. What the isotope actually means? It is the same atomic number but different mass number. That means there is difference between the neutron number. That means over here the oxygen, that is oxygen, we all know 816. Atomic number is 8, mass number is 16, but there are some isotopes present over there in the world, that is 817, 818. Here if we randomly take sample of water having these 3 oxygen atom present in them, what we will get? The mass ratio of hydrogen and oxygen will be different. Maybe it will be minute amount, but it will be different in each 3 cases. So because of the presence of isotopes in a molecule which is randomly taken from different sources, will not always give the same mass ratio because of the isotopic nature. Several other isotopes are also there. I am giving over some examples also. Here is hydrogen 1,1, that is protium, 2,1 deuterium, and 3,1 that is tritium. Maybe chlorine, there is also 1735, 1736, 1737. Many other, iodine, many other phosphorus, they are also having isotopes in the world. Now the next one, that is the polymerization. If we go for polymerization, we all know that monomers combine to form polymers. Take an example of acetylene, that is C2H2. It polymerizes, you can see the picture also, it polymerizes to form benzene. That means 3 molecules of acetylene combines, that means polymerize to form benzene. But do you know that benzene, though formed from acetylene, but differs in chemical properties? Acetylene is a gas, but benzene is a liquid. Physical property is different. Chemical properties are also different in these 2 cases. That means if acetylene and benzene, that means benzene is nothing but acetylene. The constituent elements are same. If we go for the mass ratio, they will also give the same. But it doesn't matter that the chemical properties will also be the same in the same way. Okay. Now the next one, but not the least, it is non-stoichiometric compound formation. It is very interesting because, see, if I ask you that what is the chemical formula of cuprous sulfide, we all know that cuprous it is Cu plus, and sulfide S it is 2 minus, and we will generally give the formula that is Cu2S. But do you know it may vary from Cu 1.7S to Cu2S? Another example is also there. Titanium oxide, if we think about that, we generally say it is TiO, but actually it doesn't. It may vary from Ti 0.75O to TiO 0.69. How funny the thing is. But this is due to the crystal defect. If we think about a crystal lattice, there a thing occurs like a cation can have extra positive charge. That means maybe in a normal cation is plus 1, the extra positive charge, that means it can go to plus 2 state. And to balance the charge, the crystal lattice rearrange in this way, one of the crystal lattice point becomes vacant and one cation gets missing. Hence, to get the overall mass ratio, the deficit of a cation is there, and hence the mass ratio will differ. Hence, for this type of crystal defect, non-stoichiometric compounds may arise, and that is why this is also a big drawback of the law of constant proportion. No more for today in this video. If you want me to make more videos, just go and support me, subscribe my channel, give a like. Thank you and have a nice day.